Okay, we just completed week 1, and that's the material covered for week 1. And what did we do? We covered linear inequality. We did examples in front of you. Hopefully you've been paying attention and understood that stuff. It's also the same material that was covered in Math 100. For students that need additional support, you can watch these videos on the side if that's helpful. What else did we cover? We covered polynomial inequalities. Again, we talk about the strategy for doing a polynomial inequality, which, by the way, also includes linear inequality. But polynomial is going to be something of a degree, like 2 or 3, so forth and so on. There's also a video on the side if you need help with that. But again, you need to study this material. Right, you went through a bunch of examples. Hope you remember that. Again, there's little videos on the side if that's helpful. We also cover rational inequalities. What's rational is a ratio to polynomial, and inequality, we're comparing it. So a little video on the side, again, if those are helpful. We went through a bunch of examples, all right? Okay, so what happens now? Someone says, when am I going to get a chance to try? We really want you to try the material. I mean, really, really want you to try. That is, you come to class to learn the material. It's basically a show and tell. We show you, we tell you. At some point, you say, well, I want to try too. And that's the whole thing over here about the supplemental activities. And that's what we're going to go to. Remember whiteboard. Here's the deal, though. The expectation is you've studied the material. You've come to class. You've listened. You've paid attention. You've followed the examples. And you've done the homework, the supplemental problem sets. So someone's going to say, I haven't done it yet. Watching a video of me doing the problems is not going to be helpful. You need to do this. Have these notes in front of you, including your worked solutions out. And then what you're doing is, if you're watching the video, right, if you're paying attention now, the only paying attention is to confirm what you've done is correct. I'm going to switch over to the whiteboard now and do these problems. Just give me a minute to get that thing working. Let's see what we got here. All right, let me tell you where we are. We're in week 1. We're doing the supplemental problems, which to me is homework. Right, as I go through these problems over here, again, the expectation, you've studied the material, you understand the material, and you've already worked these problems. Number 1, what do you see? Minus 5, 3x, whoops, minus 2, less than 1. Now this is called a double inequality or compound inequality. Well, the reason for compound is read with the word and. What I'm going to do is I'm going to add 2 to all sides, and there has 3 sides, by the way. What would you end up if you did that? Minus 3, 3x, and you get 3 over here. The next thing I'm going to do is divide all sides by the number 3. This is the coefficient on the x. My goal is to isolate the variable. What do you get here? Minus 1, x, and you get 1 over here. At this point, I'm going to say it's solved. And the reason it's solved is I can read it. What does it say? X is less than 1, and x is greater than minus 1. I'm going to put a graph down, put the numbers down. There's 2 numbers, minus 1 and 1. And what is x? It's between those numbers. I'll shade that in. What else we put down? Interval notation. You should know the convention now, and the convention should be reasonable to you. So I'm going to box the answers. The answers, they might ask for intervals. That's an interval. They may ask for a graph. That's the graph. And they may ask for a solution, and this is a solution to the problem. That's number 1. Again, I would look at the answer key to make sure that that's correct. Let's go to number 2. Number 2 is a rational inequality. And we have a technique for doing this. Now, granted, a lot of students say, I want to do it differently. We're not saying don't do it differently, but a lot of times people's different ideas is it's not a truthful technique, and that would be an unfortunate thing to do. For example, a lot of students now will multiply both sides by x plus 2. That's a disaster. And the reason for that, you don't know if x plus 2 is positive or negative, and that just takes too much effort to figure that out. So what I'm going to tell you is what we've been doing is we've been comparing these with 0. How do we do that? Well, the way we do that is we're going to just subtract 3 from both sides. I'll write that down for you. Next thing we'd like to do is get one term. I'm going to put one term down. That means common denominator. Looks pretty simple. All right, let's keep going. Let's see what you get. Let's see, you get x plus 12 minus 3x minus 6. Let's keep going. And I get 6 minus 2x and x plus 2 less than 0. So what we've agreed upon when we're doing these problems over here is we agreed upon that if you have a rational inequality, that what we want to do is get one term completely factored compared to 0. And we almost have that. I'm just going to factor it for you. 2, 3 minus x. The bottom factored is x plus 2. And what we told you to do is list the zeros on the number line of both the numerator and the denominator. And what are the zeros going to be? Well, one of the zeros on top would be at 3. The top becomes 0 at 3. Now, certainly when I say it becomes 0 at 3, it splits its sign there at the 0. It goes between plus and minus. The other 0 is the one on the bottom. And when does that become 0? When x is minus 2. Then what we told you to do is take test points. Right? We've been trying this because otherwise, if you're letting somebody else try your work for you, you'll never be able to master the material. But I'm going to write it down for you. I'm going to write the test points down for you. So I'm going to put a test point here. I'm going to say x equals, what's a good number between minus 2 and 3? I would say 0. I'll do a test point over here. And someone says, what's a good test point after 3? I would say 4, but any number will do as long as it's after 3. What's a good test point over here? I would say x equals minus 3, but any number below minus 2 is fine. Then what do you do? Plug it in. Plugging it in, generally speaking, should be very easy because you're not looking for a number. You're just looking for a sign. And why is that? We're comparing it to 0. That's the only reason we want to know the sign. So negative numbers are less than 0. Positive numbers are greater than 0. So let's do this, see what happens. And let's go back, and I'll test them out. So let's do 4 first. All right? If you plug in 4 on top, what'd you get? You get a negative number. If you plug 4 at the bottom, what do you get? A positive number. You should know that a negative divided by a positive is a negative number. All right, let's do this one. I'm going to plug it in top. Plug what in? 0. What do you get? Positive on top, positive on bottom. Overall, what do you have? Positive number. Let's do this one over here. And that would be minus 3. We'll plug it in. What do you get on top? Positive number. And what do you get on bottom? Negative number. Yes, you need to know simple arithmetic to do that. What do you get over here? Negative number. What's the question though? I want to point it out to you. The question is, when is it less than 0? Well, when it's negative. So I'm going to shade that in now. And it's negative over here. I'll shade that. And it's negative over here. All right. So I'm going to, put the intervals down now. Push this up. And I'll write the intervals down for you. So I'm looking at it left to right, minus infinity. Again, you should know the conventions we're using. Up to minus 2, union 3 to infinity. Okay, so what I want to do is look at the answer key and see if you're staring at that. And if you're not, there's something wrong with it. And we are. Number 2 is done. Let's go to number 3. And what's number 3? X over 3. Greater than or equal to 2 plus x over 6. Well, a lot of students are still struggling with fractions, so our recommendation is to multiply both sides by the LCD. What's the LCD is 6. I'll write that down for you. Some students often question, do I need to write that down? I don't know. That's something, if it's helpful, write it down. If it's not helpful, don't write that down. Now, what do you get over here? 2x. By the way, 6 is a positive number. It has no effect on inequality. 2 times 6 is 12, and x over 6 times 6 is x. The next thing I would do is I subtract x from both sides. This is a linear inequality. And what do you get? You get something pretty simple. You're going to get x greater than 12. This is a solution to the problem. It can be easily read. What does it say? X is greater than or equal to 12. Put the number line down. What goes on the number line? The number of interest, which is 12. X could be equal to 12. I'll shade that in. What else could X be? Reading it, it says X could be greater than 12, which means I shade that section of the number line. What goes over here? Intervals, 12 to infinity. All right, this is the graph. You could be asked for that. And this is what's known as interval notation. What's given you in the answer key is the intervals. All right, that's really our goal, by the way. Let's take a look at number 4. Again, at some point, these problems should become very simple to do because they're written to be simple. Whoops. This is a polynomial. Its degree is 2, and we have a technique for solving this. And what's that technique? Compared to 0, completely factored. Let's put this down. Okay, we got that. We've got it completely factored compared to 0. Put the zeros down. What are the zeros? Plus or minus 1. And what are we going to do now? We're going to do some test points over here. And I'll write them down for you. So a test point between minus 1 and 1 would be x equals 0. A test point after 1 would be like x equals 2. A test point before minus 1, you might say x is minus 2. Let's test it out, see what we get. So for example, if I chose 2, what would I get? I'm plugging it in. I would get plus, and plus is definitely a positive number. So this is positive here. All right, that's done. Let's do this one. You plug 0 when you get negative times a positive, which I know to be a negative number. Again, that would be negative overall. Let's do minus 2. What would you get? A negative number times a negative number, which we know, I'm sorry, I said minus 1 there. I should have done that. I don't need to know the number. I need to know its sign, and that's positive. So this is overall positive numbers over here. What's the question now? When is it greater than 0? Right? I want to point that out to you. This is the question. When is it greater than 0? Well, when it's positive. So I'm going to shade that in for you. It's positive here. And it's positive here. What's the other question? When is it equal to 0? Well, if you plug in minus 1, that would make it 0. And if you plug in 1, it would make it 0 as well. So I got my answer. There's an rotation, minus infinity, up to minus 1. That's inclusive. 1 off to infinity. Okay, let's read the answer key. And you should be staring at those answers. And if you're not, there's something wrong with it. And it really it's that simple. All right, let's go to number 5. Again, at some point, I'm going to get faster at this. And I want to encourage you when you're starting to do work, you're going to get faster at it. Initially, though, getting started is the tough part. I'm going to subtract 2 from all sides. This is a compound or double inequality. And what would you get? 2, 2x, 8. I'm going to divide all sides by 2. 2 is a positive number. It has no effect on inequality. And what would you get there? 1. Whoops, I didn't do that. Go backwards. That's a solution because it can be read. What does it say? X is less than or equal to 4 and X is greater than or equal to 1. Put my number line down. There's 2 numbers on my number line, 1 and 4. It could be equal to 1, it could be equal to 4, and it's in between those numbers. That's a graph. And the intervals would be from 1 to 4. Again, my recommendation, look at the answer key and make sure you're agreeing with that. All right, let's go to number 6. Again, a lot of students make mistakes because they're not following the structure that we're presenting to you, and they think they can do it differently. We say you might be able to find a different technique, but this is the technique you want to follow. It's going to lead to a truthful answer every time. So what do you get? 1 over x is less than or equal to 4. All right. So what a lot of students fear is they multiply both sides by x, and this really is, it's suicide. So what I'm going to explain, the technique we have is a rational inequality. It's 1 over x. It's being compared with 4. We don't want that. We want to compare it to 0. That's our first step. Next step is one term completely factored. Well, I notice over here, I can just put factor symbols on this, and now this thing has become completely factored. Now what do? We're going to list on the number line those numbers where the top becomes 0 and the bottom becomes 0. Well, the bottom becomes 0 at 0. The top becomes 0 at the number 1/4. What am I going to do now? I'm going to take test points. Now, someone says, what test point you're going to use? I'm going to say a test point over here, any number below 0, for example, -1. Now, here comes the top bar for some students. What's a good test point over here? I'm going to recommend using a decimal. Now, 0 and a quarter is 0.25. I'm going to say 0.1. Test point over here. Again, you're free to use other numbers, provided those numbers are between 0 and 1/4. Now, after 1/4, a good test point would be 1. Let's plug it in and see what we get. I'm going to try -1 first. What kind of number you get on top? A positive number. What number do you get on bottom? A negative number. What does that give you? A negative number overall. So this is negative. I know that much. Right, I'm going to go to 1 now, and because I think it's easy. If you put on top, you get a negative number. And if you plug in 1 on the bottom, you get a positive number. What kind of number you get over there? A negative number. So this interval is all negative. Now let's do the 0.1. What would you get? On top, you get 1 minus 0.4, which is a positive number. And on bottom is a positive number. What does that give me? A positive number. Okay, I'm going to read it to you. As I'm reading something to you, you should also read these things. There's 2 questions. When is it less than 0? Or when it's negative? The other question is when it's equal to 0. Well, I'm going to shade in the negative parts first. It's negative here. It's negative here. This gets all shaded, the whole interval. The other question, when equal to 0, what 1/4, this ratio would be equal to 0. I want to put what I'm looking at. This ratio becomes 0 at 1/4. Unfortunately, 0 cannot be shaded in. And why is that? The bottom becomes 0, and you can't divide by 0. Let's put our intervals down, and it should be relatively simple to do that now. What's the interval going to be? Minus infinity up to 0, union. By the way, our goals are intervals, right? We want to put these down if we can to infinity. Okay, look at the key. And if you're not staring at that, you know you did something wrong. It's that simple. All right, let's go to number 5. And again, at some point, did I say 5? I think we just did 6, didn't we? I don't want to go backwards. I want to go to 7. That's crazy, right? Let me just go backwards here. I'm going to 7. And that's 1 minus 2x. I'm going to subtract 1 from both sides. You notice I'm not writing that down, by the way. That was easy. I'm going to divide both sides by -2 now. There's a problem here. If you divide by -2, the direction of the inequality changes. That's a solution to the problem. Let's put our interval down. I'm sorry, our graph down. -1. It could be equal to that. What else could it be? X could be greater than that. This is a graph. Intervals, -1 to infinity. If you notice my answer key, though, I put down the interval for you, and that's really our gold standard in solving inequality, the interval. Let's go to number 8 now. And again, at some point, you're going to get very fast at this when you start to practice. If you don't practice, though, you're never going to get quick at this. Technique, it's quadratic I'm going to have to compare this to 0. It's done. Next step, factor it. Chances are this is going to be incredibly easy to do. It's done factoring. Number line. What goes on a number line? The zeros. All right, test points. I'm getting better. I'm going to take a number between -1 and 8, like 0. Plug it in, positive times a negative. I hope you know that's going to give me a negative result. All right, let's take a number after 8, like 9. Plug it in, positive, positive. A positive times a positive is a positive. I'm going to take a number below -1, like -2. Plug it in. You get a negative times a negative, which is a positive. What's the question? The question is this. I'll point it out to you. When is it greater than 0? Only when it's positive. I'm going to shade that in for you now. Here and here. Let's write the answer down. Put a box on it. That's an interval. Look at the answers. Make sure you're staring at those answers. This is all typed up here for a reason. We want to make sure you're looking at the answers. All right, let's go to number 9. Number 9 is a compound inequality, and it's -8. I'm just simply copying at this point. -8. I'm going to simplify. And yeah, I'm just simplifying. I can subtract 7 from both sides. Shouldn't say both sides, all sides, right? There's 3 sides. So I'm not writing it down. I'm just saying at this point. Subtract 7 from 13, you get 6. And now I'm going to do something dangerous. I'm going to divide all the sides by -3. What happens when I do that? The direction of the inequality is going to change. So when you divide -15 by -3, you would get 5. -3x by -3, you get x. And 6 divided by -3 would be -2. This is a solution to the problem. It can be read. How's it read? X is greater than or equal to -2, and x is less than or equal to 5. Number line. 2 numbers go down that number line in order, -2 and 5. They can be equal to those numbers. And what else is it? It's between those 2 numbers. What's the answer over here? -2 up to 5. And again, this is an interval. Do mistakes happen? Of course they do. And this is why we want to give you an answer key. Please verify that that's the answer you're looking at in your answer key. Let's go to number 10. And again, we should be getting faster as we move through the problem set. It's already compared to 0, and it is rational. So what I'm going to do is common denominator. That'll be 1 minus x squared. I need to factor this thing. But I'll be honest with you, over time, you may not factor it. You may see the zeros very quickly. What goes on a number line? The zeros. The 0 on the bottom is that 0. The zeros on the top, there's 2 of them, plus or minus 1. All right? So what I want to do now is I want to test things out. But again, I think I'm getting better because I've tried. What's a good number after 1 to choose? I would say 2. And if you plug 2 in, what do you get in top? Negative, positive, positive. Overall, it's negative. I'll write that down for you. Let me try another test point. I'm going to go over here. I'm going to use -2. If you plug in -2 here, you get a positive, negative, negative, right? Positive, negative, negative. So what do you get? Positive. All right, let's keep going. Let's take a half. Positive, positive, positive. Everything is positive. I'll write that down for you. All right, let's take minus a half. We're in this direction over here. Positive, positive, negative. That's going to give me a negative number. All right, we're going to answer the question now. So I don't know what the question is. You have to read it. What's the question? When is it greater than 0? When it's positive. What's the other question? When is it equal to 0? Well, if you plug in -1, you'll get 0. If you plug in 1, you'll get 0. Unfortunately, if you plug in 0, you get a division of 0. So that's not good. Let's write our intervals down. The interval is going to be, looking at my number line, minus infinity, -1, inclusive, union, 0, don't touch that, up to 1, inclusive. Look at the answer key. If you're not staring at that, you're staring at a wrong answer then, all right? We need to be in agreement with the truth, all right? And I feel pretty good about that. Let's go to number 11, relatively simple question. And that's x over 2. I'm going to multiply both sides by 4. I'm going to add x to both sides. And then I'm going to divide both sides by 3. That's a solution. What is x? It's less than or equal to 4/3. I'll put my number line down. 4/3. X could be equal to 4/3. What else could x be? Less than that number. Okay, that's a graph. Put the intervals down. Minus infinity up to 4/3, touching it. Look at the key. Make sure you can agree with the key. If you can't, please rethink what you've done. If you really need to come by during office hours for this, don't hesitate to do so. Let's go to number 12. And what's 12? X squared plus x greater than 12. It's a quadratic inequality. And what I'm going to do is get it compared to 0. I'm going to factor it. That would be what? 3 and 4, right? Plus 3 minus 4. List of zeros. And this should be very quick, by the way. -4 and 3. Take the test points out. What's a good test point to choose? I'm going to kind of do it quickly. And I'm doing this over here. I better know what the question is. The question is, when is it positive? That's its only question. When is it positive? Nothing about 0. So let's take a look at it. What's a good number between -4 and 3 to choose? 0. And if you did that, what would you get? A negative times a positive. So this would be negative. That can't be shaded. Let's try this over here. What's a good number after 3? 4. Plug it in, what do you get? A positive times a positive, which is a positive. Positive numbers are greater than 0, so I'm going to shade this in. You notice I'm getting faster now. Let's keep going. Let's go below -4. What's a good number? Like -5. Plug it in, you get a negative times a negative. What's a negative times a negative? A positive, and positive numbers are greater than 0. So I'll shade that in. Intervals, minus infinity, -4, union, 3 to infinity. Again, do mistakes happen? Of course they do, but let's check and see how we've done. And I'm looking at my answer key. I'm in agreement with it. Let's go to number 13. And again, for some students that get tired, you take a break if you're tired. You want to try to get your stamina up. All right, so what do you get? 3x minus 5 over x plus 2 less than 2. And again, a lot of students start the problem incorrectly by multiplying both sides by x plus 2. That's suicide. Let's go through the technique. 3x minus 5 over x plus 2 minus 2 less than 0. Common denominator. That would be x plus 2. 3x minus 5 minus 2 times x plus 2. What do you get now? Well, it seems like work, but we want to encourage you to do that work. What do you get on top? Well, 3x minus 2x is x. Minus 5 minus 4 is minus 9. All right, I feel pretty good about that. I got one term completely factored compared to 0. Yeah, a lot of work. Number line. The 0 is going to number line. The top 0 is 9. The bottom 0 is minus 2. Take some test points. A good test point after 9 would be 10. Plug it in. Top would be positive. Bottom would be positive. A positive by positive is positive. Positive numbers are not less than 0, so this would not be shaded in. Let's go between minus 2 and 9. A good test point to choose would be 0. You get negative on top, positive on bottom. You get negative overall. And negative numbers are certainly less than 0. So I'm going to shade this in now. Let's keep going. Let's go below minus 2. Like, minus 3. The top would be negative. The bottom would be negative. And a negative by negative is positive. And positive numbers are not less than 0. So I'm done. I'm going to write my answer down now in interval notation. Minus 2 up to 9. Look at the key to make sure you can agree with that. All right, let's go to number 14. And what's 14? I'll write it down for you. X squared plus 7x less than or equal to minus 12. Again, for a lot of students, this becomes very repetitious. They say, why do you keep doing the same problems over and over again? This is going to happen in exams as well. It'll be really the same problems over and over again. We're not going to extend much beyond the concepts that we're presenting to you. All right. I shouldn't say much beyond, never beyond. It's really the same level. So let's go through the technique. And I'll get faster as I practice. Compare it to 0. Factor it. And let's see. I'd say 3 and 4, right? Let's write this down. Number line. Let's see. Minus 4. Minus 3. Yep, they got to be put down in proper order. I'm going to start testing it out. So what do you mean testing it out? I know there's 2 questions. And one of the questions, when is it less than 0? When it's negative. Let's see what happens. What's a good number over here? 0. Now, if you put 0 over here, what would you get? Positive, positive. Well, that's not less than 0. Let's do this. What's a good number between minus 4 and minus 3? I would say minus 3.5. Positive, negative. Well, that's a negative number, so this gets shaded in. All right, let's go below minus 4, like minus 5. You would get negative times a negative, which is a positive, and positive numbers are not less than 0. What's the other question? When is it equal to 0? Well, if we put in minus 4, this becomes 0, and minus 3 would make that 0. So it becomes 0 at these 2 places here. Intervals, minus 4 up to minus 3, inclusive. Look at the answer key, and you should be staring at that answer. All right, let's go to number 15. Looks like a straightforward, simple question. And what's 15? X plus 3 over x minus 2 less than 0. Again, it's rational. One term compared to 0. I'm good to go. Put my zeros down. Minus 3 and 2. Do some testing. What's a good number after 2? Like 3. Positive, positive. A positive by positive, positive. That's not less than 0. That doesn't get shaded. What's a good number between minus 3 and 2? 0. What would you get? Positive on top, negative on bottom, and negative overall means it's less than 0. So this gets shaded in. Let's keep going. What's below minus 3, like minus 4? You get negative on top, negative on bottom. A negative divided by negative is a positive, and positive numbers are not less than 0. I am done. What's the answer? Minus 3 up to 2, not including. Look at the answer key and make sure you're looking at that. Let's go to number 16. Again, relatively simple questions. My practice is proving that it's going to allow me to do these things very quickly if I practice. I'm just copying, by the way. It's a double inequality. I'm going to multiply both sides by the LCD. So what's the LCD going to be? 12, all right? Multiply all sides by 12. What do you get? 6 4x plus 4 and 9. Subtract 4 from all sides and divide all sides by 4. That's a solution. Let's put down the intervals. I'm sorry, the graph. I'm sorry, I just meant to say intervals. 1/2. Whoops, made a mistake there. Got to get my eraser out. And we have an edge key to look at. What is x? Well, reading it, it's less than 5/4 and greater than 1/2, which means it's in between those. What else is it? It could be equal to 1/2. This is the graph. What's the interval going to be? 1/2, comma, 5/4. Don't touch it. Look at the answer key. Make sure you're looking at that. And we're looking at that. And I feel good about that. Let's go to 17. 17 is x squared plus 4x plus 4 greater than or equal to 9. It's quadratic inequality. I'm going to subtract 9 from both sides. And let's just hope these things work out really nicely. So far, they've been working really nicely. Again, compare it to 0, completely factored if we can. So I got 5 and 1 plus 5 minus 1. Number line. The zeros go down number line, which would be minus 5 and 1. Let's see. I'm getting much, much better at this now. What is equal to 0? At minus 5, if I plug in, I get 0. And at 1, I get certainly a 0. And let me just test it out now, okay? And I'm just go in between. What's a good number between minus 5 and 1? 0. And if you plug that in, what would you get? Negative times a positive, which is negative. And negative numbers are not greater than 0, so I would not shade this in. Let's go over here. What's a good number after 1, 2? Positive, positive. Positive times a positive, positive, and positive numbers are greater than 0. So I'm going to shade this in. All right, let's keep going. I'm going to go where now? Below the minus 5, like minus 6. Negative number times a negative number. That gives you positive numbers, and positive numbers are greater than 0. So that gets shaded in. What I'm going to do now, list the answer in interval notation. Minus infinity, can't touch that, up to minus 5, inclusive, union, 1, inclusive, off to infinity. Now granted, when you start to practice, you're going to make mistakes. That's the whole point of giving you an answer key. Look at the answer key and make sure you're staring at that. And we are. Let's go to number 18. And what's 18? A rational inequality. And again, it's really getting much simpler as I start to do problems. It's rational inequality. There already is one term. It's compared to 0. Let's list the zeros. At 2 and at 5. All right, I'm going to do the 0 first. So if I plug in 5, I get a 0. 2 doesn't work, by the way, because you have a division by 0. So that's done. Now let's do the signs. How am I going to do that? Pick a value. I'm going to do over here first. What's a good number after 5? 6. You should know what the question is. When is it greater than 0, which means when is it positive? Well, if you plug 6 here, you get a positive number. If you plug 6 here, you get a positive number. And a positive divided by a positive is a positive. So this is definitely an interval that should be shaded in. It's a positive interval, and that's certainly greater than 0. All right, let's go to the next one. And I'm going to be between 2 and 5. I'm going to say 3, but you're free to choose any number between 2 and 5. So if you chose 3, what would you get? Negative on top, positive on bottom. That would be negative overall, and negative numbers are not greater than 0. Let's go below 2. What's a good number below 2? 0. Let's plug it in. What would you get? A negative number on top and a negative number on bottom. And a negative divided by negative is a positive, and positive numbers are certainly greater than 0. So I'm going to shade that in. Let's put our answer down, which is intervals, minus infinity, up to 2, union, 5, off to infinity. Look at the answer key and make sure you're staring at that. And of course you are. All right. Let's do number 19. The more practice you put in, the better you get at this. And what's that going to be? X plus 6 over x plus 1 greater than or equal to 2. Well, again, one term. It's rational, by the way, compared to 0. Let's write this down. Yes, some work. There's my 0. One term. And yeah, you would need to know, basic 0-level algebra to do that kind of work there. So what would you get over here? Let's take a look. We get x plus 1 in the bottom. That's not a problem for me. I'll put the factor symbol on it. And what do you get on top? You get x minus 2x is minus x, right? And you get 6 minus 2, which is 4. All right, so I got that part covered. Number line. What goes on the number line? Numbers that make the top 0, which would be 4. And the numbers that make the bottom 0, which would be minus 1. All right, I'm going to do the 0 first because I think it's easy. When is it equal to 0? When x is equal to 4. By the way, minus 1 doesn't get shaded in because minus 1 make it a division by 0, and that's simply unacceptable. All right, let's talk about testing. What's a good number after 4? I say 5. Plug it in here. What's the question, though? When is it greater than 0, which means it's positive? If you plug 5 in here, what would you get? A negative number. This would be positive. So what kind of number do you get? A negative number. Don't shade that in. Let's go between minus 1 and 4. What's a good number? 0. Plug it in. Positive on top, positive on bottom. A positive divided by a positive is a positive, and positive numbers are certainly greater than 0. So I'm going to shade that in now. Okay, let's go below minus 1. Let's go below minus 1, minus 2. Positive on top, negative on bottom. Positive divided by negative is a negative, and negative numbers are not greater than 0. I am now ready for my intervals. This is our goal. Let's look at the answer key, and that's what we're staring at. Let's take a look at number, what's that? It's 19. We'll go to 20, right? And again, the more you do, the easier these become. In fact, so easy that they become less and less challenging over time. So what do you get here? Well, let's give it a try to factor it. It looks tough, but I'm assuming I can do it. I'll say 3x and x would give me 3x squared. I'm say I need a 4. I'm going to put a 4 and a 1, and minus and plus. And let's just see if that works out. What do you get? 3x squared. Looks pretty good. Minus 12x plus 1x minus 11x. That looks pretty good. And we do get minus 4. What goes in the number line? The zeros. So I'll put out 1's pretty easy. It's, x minus 4 becomes 0 when x is 4. And I want to put the other one's really kind of easy too, but you may not like it because it's a fraction. It's minus 1/3. All right. When is it equal to 0? At 4, certainly. Plug it in, makes it 0. And when is it equal to 0? Also at minus 1/3. If you plug it in, you get a 0. All right, let's do the test. And I want to go to this place over here. 5. Plug it in. Positive times a positive is a positive. Positive numbers are not less than 0, though, so this doesn't get shaded in. Let's go to this interval. What's a good number between minus 1/3 and 4? I would say 0. Positive times a negative is a negative number, and negative numbers are definitely less than 0. So I'm going to shade that in now. Let's go below minus 1/3. And what's a good number below minus 1/3? I would say minus 1. What do you get up here? Negative number times a negative number would be a positive number, and positive numbers are not less than 0. So I am done. I'm going to write my intervals down, and then I'll look at the answer key. Look at the answer key, and we, of course, are staring at that. All right, let's go to 21 now. Boy, this looks like an easy one, and they should be. They really should be easy. Let's put 21 down for you. X cubed less than x squared. Well, it's polynomial inequality. It's not linear. I'm going to subtract x squared from both sides. I'm going to factor it. And now I'm going to put my number line down. What are the zeros? At 0 and at 1. What am I going to do now? Test. I know it's annoying to test, but you want to be able to test without bias too. So I'm just wondering when it's negative. And why is that? It says, when is this thing negative? Well, let's go over here. What's a good number after 1? I'd say 2. Positive. This would be positive. Well, that's certainly not negative. I wouldn't shade that in. Let's go over here. What's a good number between 0 and 1? I would say a half. Plug it in. What do you get? Positive times a negative. So that gets shaded. Oops, I go back to black. Sorry about that. Okay, let's go below 0. All right, what's a good number below 0? Let's say -1. What do you get over here? This would be negative. This would be positive. By the way, this is always positive. So it's negative. Negative numbers are less than 0. I'll shade that in. This has nothing to do with inequality. So I'm going to write my answer down now. What's it going to be? Minus infinity up to 0, union 0 up to 1. Look at the key. Make sure the key says the same thing, and it does. All right, let's go to 22. And again, a lot of redundancy over here. We just think practice is good. All right, decimals, they do cause troubles. It's a linear inequality, though. It should be very, very simple to do. So I'm going to subtract 1.5x from both sides. You would get 0.8x. And I'm going to add 5.2 to both sides. And what would you get? You get 8.8. Whoa. I'm going to divide both sides by 0.8. And that would be x. And that goes in 11 times. Yeah, not bad. I know what x is, by the way. What is x? Less than 11. Put my graph down. 11. What's x? It's less than 11. Intervals, which is our goal. Look at the key. Make sure you can match it. And of course, we're matching it. Very simple question. Let's go to 23. And again, we're not trying to trick you. We're just trying to follow the method that we're talking about. Now, of course, I'm not going to write the problem down now. You're getting really kind of tired of writing the problems over and over again. We're going to look at it and do the problem. What do you see? Factor the top. Whoops. And factor the bottom. And list the zeros. What are the zeros at the top? Plus or minus 3. What are the zeros at the bottom? 3. That's already listed. Let's go through it. When does it equal 0? When x is minus 3, certainly. However, 3 doesn't work because the bottom becomes 0. Now we're going to test it out. So what does it mean test it out? You're going to look at these intervals, take a number, any number you want, after 3, like 4. What would you get? Positive, positive, positive. Positive numbers are greater than 0. So that would get shaded in. Okay. We're going to go between minus 3 and 3, and we're going to plug it in. And what's a good number between minus 3 and 3? I would say 0. And you're going to plug it in. What would you get? Positive times a negative, which is negative, divided by a negative by a positive. So this gets shaded in. Oops, let's get the shading in, right? Let's go below minus 3. What's a good number below minus 3? Like minus 4. Negative times a negative is a positive, divided by a negative. Overall, it's negative, and that's certainly not greater than 0. So I'm ready to write my answer down now. And what's my answer going to be? Let's write this down for you. Minus 3. We'll look at the key later. Up to 3. union 3 off to infinity. Look at the key. Make sure you're looking at that key. We're giving you the same answer. All right, let's go to 24. At some point, these should be very simple questions for you. That only comes from practice, by the way. Could we write problems that are difficult? Of course we could, but we just don't. X plus 8. Number line. The zeros go down. There's 2 of them, minus 8 and 0. It becomes 0 at minus 8, and it becomes 0 at 0. Plug a number in, any number you like after 0. I would say 1. You get 1 times 9, a positive times a positive. They're not less than 0. This doesn't get shaded in. Let's go between minus 8 and 0, like minus 1. That'll be a negative number times a positive number. That's a negative number overall, and it is certainly less than 0. Oops. Let's go below minus 8, like minus 9. Plug it in. That'll be a negative number. That'll be a negative number. A negative times a negative is positive. It's not less than 0. I'm ready for my answer. What's my answer going to be? Minus 8 up to 0, inclusive. Look at the key, and you're looking at the answer. All right, let's go to 25. And I'll put 25 down for you. Again, it's a long problem set for some students, but again, the more time and effort you put in, the easier these become. 4 minus 3, 1 minus x. What do you get here? 4 minus 3 plus 3x. It's a linear inequality, by the way. 1 plus 3x. Take away 1 from both sides. Divide both sides by 3, which is a positive number. So that's pretty good. I know my solution to the problem, and that's x is less than 2/3. I know what the graph looks like. X is less than 2/3. And I know what my interval looks like. Minus infinity up to 2/3. Now I repeat this, mistakes can happen. You want to rectify mistakes if they do happen though. I'm looking at the key, it looks pretty good. Let's go to number 26, really the last problem. And you should spend a lot of time studying and working problems. Get it compared to 0. Let's see, minus 3. Boy, these are really working out smoothly, aren't they? I'm going to check it though. 2x times x is 2x squared. Minus 6x plus 1, x is minus 5x. Yeah, looks pretty good. Number line goes down. On that number line, the zeros, which would be 3. The other one would be minus 1/2. You should be get bettering at the testing. For example, the really question is, when is it less than 0? Well, put 4 in here. What do you get? Positive times a positive. Well, positive numbers are not less than 0. Let's do this. 0 is a good choice. This becomes a positive number. This becomes negative. A positive times a negative is a negative, and negative numbers are, in fact, less than 0. So I'll shade that in. Number below might have like minus 1. You plug it in. This becomes negative. This becomes negative. A negative times a negative is a positive, and positive numbers are not less than 0. So I got my answer, and my answer is going to be this over here in intervals. Minus 1/2, comma, 3. Look at the answer key, and you're staring at that. Okay, so I'm going to switch screens now, and I want to just briefly go through that co-calc business with you. All right, so just give me 1 second. I know this is long and tedious for some students to follow. Okay, so we finished the problem set. All right, now, so I say finish problem, but you really need to finish the problem sets. So what I want to do is I want to just, go this related stage code. So, certainly we'd love for you to start thinking about moving forward in your careers. And part of that, if you're in a STEM-related career, is your ability to, maybe do a little coding initially. Hopefully, you start to, experiment with things. And you say to yourself, well, I don't like doing that. And then you switch over to something you do like. But we're going to try to get your feet wet in coding. So I'm going to go to this website called Sage Math. Let me click on that link. It's a red link. It'll open up a website called sagemath.org. You can install the software. I do know a lot of our students have trouble installing software. One of the reasons is some of our students are running Chromebooks, and Chromebooks It's really tough to install software. But if you're using a computer that allows you to install software, you can download the application. But again, a lot of students have a tough time with that. So I'm going to say as a low bar, click on this link over here. If you click on the CoCalc, what's going to happen is it's going to launch a web-based application that allows you, I got to log in, sorry. It allows you to run, you might have to create an account, by the way. It'll allow you to run, let's see what I got over here. Let me just click here, CoCalc. Something weird happened here. Let me go to my account. Projects. Give me 1 second here. Oh, right here. I didn't see it. Something new. They changed the interface today. Create a new project. Let's call it, I don't know. Call it today. Create the project. All right, give it a second to load. Let's create a file. I want to do a Sage worksheet right over here. By the way, they're asking me to pay for this. Don't worry about it. You don't have to pay for it. Reset. Okay, so what are you doing over here? I'm just typing in what I'm seeing over here. When I put down Sage with the colon there, I'm saying these are the commands you're giving Sage. Now here's the lesson. They don't know what to do. What do I do now? Let me repeat this. You got to do something to get the machine to react to it. You can hit the shift and then the return button. And what's going to happen is it's going to actually reset the instant of this particular version of this open document so everything is clean. Then I'm going to type in x equals var. I'm just looking at what I got over there. Shift return. Now what it is to find a variable. Now what I want to do is, I get tired. I'm going to copy paste. That's what I did. I copy paste. Shift return. All right, it's working, by the way. So why is it working? It's blinking. It actually writes down the answer. What does it say? X is greater than -1/2. You could actually go back and do another problem. Let me just point out what I mean by that. So let's say I want to take this code here and reuse it. And I want to solve the problem number 26 in notes. 2, you're going to have to use a star for multiplication. X squared less than 5 star x plus 3. Okay. Now you might be confused what happens now, but let's see what happens. Shift return. What does it say? And by the way, I did it quickly. It says x is greater than -1/2 and x is less than 3. Exactly what we have in the key. Hopefully this has been helpful. As my little introduction, you're not going to be tested on Sage. However, if you plan to move forward at Essex County College and move to a 4-year university, most four-year universities are going to expect that their students are capable of using what's known as a computer algebra system. And this is a good place to get your feet wet. All right. You'd also help get your feet wet in coding, which is Python. All right. Thank you.